Hi everyone, welcome to our next lesson, 12.2. We're doing tree diagrams in this lesson. So what we're doing is we're finding more basic probability, but we're using tree diagrams to help us. So first we got to define two terms. Replacement is when a population element can be selected more than once, meaning that we might draw something, we put it back in the mix, and then it can be chosen again. When we are sampling with replacement, it makes it an independent event because it doesn't change the other probabilities of happening. And then without replacement means that we don't put it back. So when a population element can be selected only one time, so it cannot be chosen again. That makes that situation a dependent event because then the probability changes from the next event. So that's what those two terms mean. So here we have a bag that contains 1 penny, 1 nickel, 1 dime, and 1 quarter. Now we're going to choose 3 coins at random, and we're not going to put it back. It says that there's no replacement, so once I pick a coin, I'm not going to put it back in the bag again. So let's make a tree diagram of what could happen. And you guys have a lot of room on your notes to write this out. I should probably make a little bit more room for myself as well, because this does take up a lot of room. So I just want you to be aware of that. Okay. So, if I have a bag that contains a penny, a nickel, a dime, and a quarter, I could draw a penny first. It's also possible that instead of drawing a penny first, I could draw a nickel first. If I don't draw a penny or a nickel first, I could draw a dime first, or I could draw a quarter first. So write down all 3 of those on the left-hand column of your piece of paper. Now, let's just say I draw a penny first, okay? If I draw a penny first, then there is one of 3 possibilities that could happen. The next one, I'm not going to put a penny back after I've drawn a penny, so now I cannot draw a penny. So I could draw a nickel, a dime, or a quarter. One of those 3 options has to happen. Now, let's say I draw a penny first, and then I draw a nickel. Well, I'm not going to put the penny back, and I'm not going to put the nickel back, so now I only have 2 options in the bag. It could either be a dime, or it could be a quarter. So there's one possibility of choosing 3 coins, penny, nickel, dime. Or I could pick a penny, nickel, and a quarter. Let's say I pick a penny, a dime. Now the next 2 possibilities is either a nickel or a quarter. Or if I draw a penny first and then a quarter second, then the next 2 possibilities is a nickel and a dime. Does that make sense, everybody? I hope that that you're feeling okay with this. So now, if I draw a nickel first, again, there's 3 options. I could draw a penny second, a dime, or a quarter. Well, if I draw a nickel first and then a penny, it could be a dime or quarter, nickel, dime, penny, quarter, or a nickel, quarter, penny, dime. Okay? Now we're on to dime. You can see how this kind of gets scrunched up, so I hope that you're writing nice and neat. If you have to erase, feel free to pause the video and erase and maybe write it a little bit neater. So if I draw a dime first, I could draw a penny second, a nickel second, or a quarter second. If I draw a dime, penny, it could be a nickel and a quarter for the last draw. Dime, nickel, penny, quarter, or dime, quarter, penny, nickel. Okay, last one. If I draw a quarter first, I could draw a penny or a nickel or a dime. If I draw a quarter penny, then it could be nickel for the 3rd draw or a dime for the 3rd draw. Or quarter, nickel, penny, dime. Or quarter, dime, penny, nickel. So those are all of the possibilities that there could possibly happen. When I draw 3 coins from a penny, nickel, dime, quarter, there are 1, 2, 3, 4, 5, 6 possibilities of having penny first. Or 6 possibilities for nickel, 6 for dime, or 6 for quarter. So there are a total possible of 24 outcomes in this situation. So now that we've drawn the tree diagram, now we're going to list the sample space. So we basically list the tree diagram. Okay, so we're going to do that with abbreviations. Penny, nickel, dime is going to be our first one. Penny, nickel, dime. Or penny, nickel, quarter. Or penny, dime, nickel, or penny, dime, quarter. Or penny, quarter, nickel, or penny, quarter, dime. So that's all that can happen when, as you can see, we have the pennies first. Now let's write down all the possibilities when we have the nickel first. So nickel, penny, dime, or nickel, penny, quarter. Or nickel, dime, penny, or nickel, dime, quarter. Or nickel, quarter, penny, or nickel, quarter, dime. So those are all the possibilities when I draw a nickel first. Let's do the dimes first now. So it's dime, penny, nickel, or dime, penny, quarter. Or dime, nickel, penny, or dime, nickel, quarter. You can see how this gets a little bit monotonous, but it is a good skill to learn. Dime, quarter, penny, and dime, quarter, nickel. Dime, quarter, penny, dime, quarter, nickel. Okay, let's write down the last possibilities, and the last possibilities is when we would have the quarter first. So quarter, pickle, quarter, penny, nickel, quarter, penny, dime. Quarter, penny, nickel, quarter, penny, nickel, or quarter, penny, dime. Or we could have the quarter, nickel, penny, quarter, nickel, penny, or the quarter, nickel, dime. Or we could have the quarter, dime, penny, quarter, dime, nickel. Quarter, dime, penny, or the quarter, dime, nickel. Okay, there is our 24 outcomes. So everything that could possibly happen drawing 3 coins, we have listed in a tree diagram and the sample space. Now it makes these a lot easier to answer the questions. So let's calculate. What is the probability of drawing 2 nickels? Well, the probability of drawing 2 nickels means that we have to see a nickel coming up twice in our tree diagram. Class, because we're not replacing it, is it ever possible to draw 2 nickels? The answer is no. It is impossible because we're never putting the nickel back once it's been drawn once. So when the probability is impossible, we say it's a 0 probability. There is no chance. So now what's the probability of a quarter being chosen? So we're going to count all of the ones that have a Q in it. So we have 1, 2, 3, 4, 5, 6, 7, 8. And 9, 10, 11, 12, 13, 14, 15, 16, 17. 18. Boom. Missed one. So there are 18 possibilities of drawing a quarter. So 18 possibilities out of the total 24. And 18 24ths reduces to 3/4. When you draw 3 coins, you're likely to draw a quarter. 3/4 probability says you're going to. How about a dime is chosen, followed by a penny? And I should really put in here, directly followed by a penny. Directly followed by a penny. So a dime, and then the very next coin has to be a penny. So dime, penny. Where in our sample space is it dime, penny? Let's see here. Dime, penny. Here's one. Dime. Oh, sorry, that's penny, dime. Never mind, that's not one. We need dime, penny. Here's one. Dime, penny. Any other dime, pennies? How about right here? And right here? Any more dime, pennies? And right here. It looks like there's 4 outcomes where you would draw a dime first and then a penny directly following it. So the answer is 4 over 24, which is reducing a 1/6 probability. Okay, class, now just take a moment to think about this for a second. How would this look different if we did replace the coin? Well, the answer would be we'd have a lot more outcomes than 24. Take a look what would just happen if we took just the penny. Let's say we draw a penny first. Now, if we draw a penny first and we put it back, now instead of 3 possibilities, there's 4. Because we could draw a penny, or a nickel, or a dime, or a quarter again. And now, after we draw the second coin, we're going to put it back, and now, once again, there's 4 different possibilities again. That's a lot of different possibilities just for drawing the penny first. It could be penny, nickel, dime, quarter again. And the same thing here, the same thing here, and the same thing here. So just for drawing the penny first, there is 4, 12, 16, 12, 4, 8, 12, 16 outcomes just for the penny first. So there would be a total possible of 64 outcomes if we did with replacement, as opposed to just the 24 without the replacement. So it does make a big deal. You need to pay very close attention to whether it says with replacement or without replacement. Okay, so here, our second example, a coin is tossed 3 times to determine the number of heads and tails. Should we sample this with replacement or without replacement? So class, if we flip a coin, I record heads or tails. If I record heads, is it possible to flip that same coin without replacement? Meaning, can we take away that heads off that coin? The answer is no. So the obvious answer is that we have to do this with replacement. With replacement. So that would make each and every one of these events independent. They stand alone. The previous heads or tails doesn't affect the next coin that's flipped, so it's an independent event. Okay, so if we're going to flip a coin 3 times, the outcomes are either head or tails the first time. The second time that we flip it, it could either be heads or tails. And the third time we flip it, tell you what, it could either be heads or tails. So that's how we write that part of the tree diagram. We could do a tails first, and if a tails comes up first, it could be a head or a tail the second time, or the third time it could be heads or tails. So there's our tree diagram. So to list the sample space, we could get 3 heads in a row. Or we could get head, head, tail. That would be this one right here. Or we could get head, and then a tail, and then another head. Or we could get a head, tail, tail. If we draw tails first, or if we flip a tails first, it could be tails, head, head, or tails, head, tail. Or tail, tail, head, or there's one possibility of tail, tail, tail. So how many outcomes are possible? There are 8 total outcomes. So your denominator will be 8 on a lot of these ones. Letter C, calculate the probability of flipping 3 coins and all 3 of them landing up to be heads. Well, there's 1 HHH. So there's 1 possible out of 8 total. So the answer is 1/8. Next one, what's the probability of getting at least 2 tails? When you flip 2 coins, what's the probability or what's the likelihood of it happening that you're going to get at least 2 tails? Well, here's at least 2 tails. Here's at least 2 tails. Here's at least 2 tails. And if you draw 3 tails, or if you flip 3 tails, that's at least 2 tails. So there are 4 possible outcomes out of the 8 of getting at least 2 tails. So then the answer is 1 divided by 2. So that's how you draw a tree diagram and list its sample space and then answer some basic probability questions. We'll do some more work on this when you get to class tomorrow.